Hi everyone. In this chapter we were going to be reviewing factoring. And in our first lesson we're going to go over greatest common factoring, difference of squares factoring, and some simple trinomial factoring. But we'll start with greatest common factoring. Alright, so the very first thing we're going to look at in terms of factoring here is the greatest common factor. Let's zoom in wrong way. Let's zoom in a little bit on that. So the greatest common factor. Now what we mean by greatest common factor is when we're looking at a series of terms, what we're referring to is the largest set of factors that each of the terms shares. Okay? Now I know this is not entirely an obvious thing to do because for the most part this is going backwards to a lot of the education that you've had up to this point. Okay? Factoring is just not natural. It's more natural to expand stuff out. For example, it's far more natural to take, let's say, 3x multiplied by x plus 1. It's far more natural to distribute that to both terms and say, well, that's 3x squared plus 3x. It's far more natural it is to do that than it is to say, okay, both of those terms have a 3 in it, so it looks like a 3's been distributed. And then there's an x squared here, so there's two factors of x here, there's 1 here. So they don't both have 2, but they've each got at least 1. So I'll take 1 out. And then that's when I take 3x squared. When I divide that out of here, I get left with x. When I divide 3x out of 3x, I get plus 1. Okay, it's the same thing here, but it's this going from here to here. This is happy. This tends to be a little bit more sad, a little bit harder to do. Anyway, that's what we want to help you practice here because factoring is such an important skill when it comes to solving. So take a quick look here. Let's see if I can zoom in a little bit more on that. Okay. I've got 12x cubed minus 3x squared. Well, between the 12 and the 3, they each have a common factor of 3. And then I've got x cubed and x squared. So there's 3 factors here, 2 factors here. You always want to take out the smaller exponent. That might be the easiest way to think about that. And now, essentially, factoring is division, okay, at its basic idea here. Up here, the opposite of it is expansion, and that's multiplication. You distribute that through to get this, and now factoring is going backwards here. So this is what I took out. What's 12x cubed divided by 3x squared? Well, it's going to be 4x. 12 divided by 3 is 4. X cubed divided by x squared is x. 3x squared divided by 3x squared is just 1. And if you were to distribute this back through, that's what you'd get. Here, first of all, look at the coefficients. 8, negative 4, 4. Well, they've each got a common factor of 4. And that's it. Now, you might be tempted to say m. Well, I got m here, m cubed even, because it's the smallest there. But m isn't common to this last term. And if it's not common to all terms, it's not common. So then just divide out a 4 here, and you'll get 2m to the 4th minus m cubed. And this is a tough one. A lot of people will get this one wrong just because of a very easy little mistake here. 4 divided by 4 is 1, not 0. Okay? When we divide that out, we don't cancel out that value there. 4 divided by 4 is 1. Over here, well, I can see there's an a in both terms. There's 2 of them as a factor here, just 1 there, so I'm going to take just 1 out. And then a squared divided by a will be a divided by a is going to be 1, so and negative 1, because I'm going to take that sign there. Let's take a look at this. Look at my leading coefficients there, okay, 5 and 15. Okay, hopefully it's clear that there's a common factor of 5 there. Now, I've got x squared, x to the 1, so I'm going to take out the smaller exponent, x to the 1. Y to the 1, y squared, so take out the y. And then 15x squared y divided by 5xy. Well, the only thing that I'm going to be left over with there is an x. There's 2 x's here, only 1 there. Plus 15 divided by 5 is going to be 3. Okay, I've already dealt with that x there, but there's 2 y's here, 1 y there, so there's got to be an additional y in there. So 5xy times x plus 3y. Here. Now, okay, between the 6 and the 24, I think we can agree that there's a common factor of 6 there. Now the question is, do you take out a negative 6 or not? And the answer is, you know what, it looks better. It looks better if you can take the negative away from that. Now granted, even when I take the negative out with that, it's still in front of the whole term here, but I'm going to drop a set of brackets now, and I have now taken out, I'm going to divide negative 6, actually 24 by that negative 6 there. You'll be left with x squared minus 4. Now granted, I've still got this negative 6 up front, but what I'm left with, that looks better. And when it looks better, it's easier to work with. And you'll see that later on here. Now, there is some more factoring that can be done in a question like this, but we'll see that in a few minutes. We'll come back to an idea like that in a second. For right now, we're just looking at taking out the common factoring, and that was what was common. Here, 3, 9, 6, well, they've all got a common factor of 3. That's the easy part here. X, 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 okay, so each one of them's got an X to the 1 in it. And then I've got a Y and a Z, but they're not common to anything else here. I don't see that showing up in every term, so that's it. 3x now divided by 3x, that was 1. 9xy divided by 3x, well, that'll be 3. The x's are going to become 1 there. And then there's nothing to divide out with the y, so it just stays there. And I get a similar sort of thing happening here. This is going to be 2z when all's said and done. Okay? Whoops. Now over here. Okay, between the coefficients, 8 and 32, okay, 8 is a factor of both of those. And then look at this, I've got x squared, y cubed. Well, they're not the same variable, which means there's nothing more that's common. So the best I can do here is just simply make this x squared plus 4 y cubed. That's as far as I can go. H. All right, 10, 5, negative 25. Well, there's a factor of 5 in all of those numbers. That's about the largest I can get. And then I've got an a squared, a cubed. Well, the smallest exponent on the a is 1, so I'm going to take out a to the 1. So now 10a divided by 5a leaves me with 2a. 5a squared divided by 5a, well, the 5's will cancel. You're going to get a squared over a. That'll leave you just a single term there, a. Negative 25 divided by 5a will be negative 5, and a cubed divided by a would be a squared. Okay, now, okay, I don't particularly like the way this one is written. I'm going to put, oh, I've got one too many a's in there. I'm sorry, I screwed that up. Sorry, when I divided that out, I shouldn't have written an a there. This should have been just 2 plus a minus 5a squared. Sorry about that. Now, I'm not particularly fond of the order that this is written in. I would like to have the highest degree term first. So I'm going to rewrite this as just negative 5a squared plus a plus 2. I'm actually going to do one more thing. When I've got it written like this, I usually like to have the first term being positive. So I'm going to take the negative out. Now when I factor that negative out, they're all multiplied together. So it's going to be negative 5a. This will turn this to 5a squared positive, but it'll change the sign on everything else inside there. This looks better. It'll be easier to work with later on. Okay? Now, again, there might be some more factoring involved here, but this is as far as I want to go. I just want to take out common factors. For this last one here, 5, 10, 35. Okay, well, there's a common factor of 5 there for sure. X to the 4th, x cubed, x squared. The smallest exponent on the x is 2, so it's going to be x squared. 5x to the 4th divided by 5x squared will be x squared. Now I got that right. I screwed it up before, but I got it right here. Negative 10x cubed. Well, negative 10 divided by 5 will be negative 2. X cubed divided by x squared will just be x. 35 divided by 5 will be 7, and then the x squared divided by x squared will be 1. So just 7 times 1. So there you go. And again, maybe I could do some more factoring. I don't know. But for right now, I've taken out what's common, and that's what I was interested in at this point. Now we'll consider difference of squares factoring. Okay, now we're going to take a quick look at difference of squares. And again, it helps to see where this is coming from here. If you've got a minus b multiplied by a plus b, well now, when you distribute the terms in this binomial with the terms in this binomial, you get a squared plus ab minus ab minus b squared. Now you can't see the rest of that there, but notice that the, notice that the ab and the minus ab okay, are going to cancel each other out here, and so you're going to be left with a squared minus b squared when that simplifies. Now, that means that this is the same as this, which means that when you see a pattern like this where it's something squared minus something squared, that actually can be put backwards into factored form by simply taking the square root of the first term minus the square root of the second, square root of the first term plus the square root of the second. Okay? Now let's take a look at some examples. X squared minus 81. Okay, well, the square root will be x minus the square root of 81 is 9, and then x plus 9. Square root minus square root plus square root. X squared minus y squared. Okay, well this is going to be x minus y followed by x plus y. Okay, and we call these binomial conjugates. Same binomial really, except the middle sign is different. Okay, 3a cubed minus 12ab squared. Okay, well this is not a difference of squares. However, we just finished doing some work with pulling out common factors, so let's do that. There's a common factor of 3 to 3 and 12, so take that out. And then there's an a in both of those, so we pull out the a, and that's going to leave me with a squared from that first term minus 4b squared. So after taking out what's common, what I'm left with now is a difference of squares. So in my next step, I'm going to write out the factors. Please don't forget to write the first one that you just pulled out. So many times people will then factor this and they'll forget to write this one back down, and that's incorrect. Okay, you can't just drop that factor because you're no longer kind of thinking about it. You need to carry it through. This is going to become a minus, well, the square root of 4b squared will be 2b, and then a plus 2b. There we go. Down here. Now, okay, here's a good example of a question. This is a difference of squares because one of the terms is squared, one of them isn't. But I'm going to pull out a a negative, just to make the pattern here a little bit easier to look at. So it's going to be 9x squared minus 25. That is far easier for me to look at. And so this is going to be negative 3x minus 5, 3x plus 5. So I take out the negative to make this kind of pretty. Okay, and when it looks pretty, doesn't have the negative up front, when it looks pretty, easier to factor. Right here, 16a squared minus 49b squared. Okay, well, it's a little bit more complicated, but you know what? This is a perfect square, and so is this. The square root of 16a squared is going to be 4a. The square root of 49b squared will be 7b, and then it would be 4a plus 7b. Okay? 25x squared minus y squared. Okay, well, again, the first term is a perfect square. The square root here will be 5a minus y. Sorry, 5x. Don't know why I said that. 5x minus y, and then followed by 5x plus y. Oops. I'm sure that looks like a plus sign. Down here, same thing, we just keep going here. Notice this is a perfect square. Square root will be 2p, and then this will be minus 5, and then 2p plus 5. Square root minus square root plus square root. 16x squared minus 9, again, this will be 4x squared, oh sorry, not x squared. Shoot, the square root of x squared would just be x, so this will be 4x minus 9, followed by 4x. I've been doing so well. I don't know what is going on right here. Okay, we'll try this again. The square root of 16x squared is 4x. The square root of 9 is 3. So this will be 4x minus 3, 4x plus 3. Okay, there you go. Difference of squares. And then finally here, very similar sort of pattern. We've kind of almost seen one identical to this a little while ago. This is going to be a minus 3b, a plus 3b. Okay, so now let's just see if this is the last of those last ones. No, there's a couple more here. Keep going. Now, this is going to be a little bit more complicated because watch what I do here. The square root of x to the fourth and y to the fourth will be squared, x squared and y squared. So this will be x squared minus y squared times x squared plus y squared. Now, as soon as I do that, what I'm left with here, this is also a difference of squares. So I get x minus y, square root minus square root plus square root. But x squared plus y squared isn't, because remember, this is a difference of squares. This is a sum right here, what I'm seeing. So this would be x squared plus y squared. Over here, okay, you can kind of approach this a couple of different ways. You really should take out what's common first. You don't have to. You would see a difference of squares pop up here anyway, but then each of your terms is going to have a common factor. I got to pull out what's common here. And between 100 and 25, there is a common factor of 25, and there's also an a in both of those. And when I pull that out, I'm going to be left with 4b squared minus 1. Okay? Now, in this particular case here, this is now a difference of squares. So 25a, remember you have to write that down again. And then this will be 2b minus 1, 2b plus 1. Now that thing's fully factored. Now if you just took out a common a at the beginning and then factored 100b squared minus 25, so you did it like this. You took out, for example, the a, and then you had 100b squared minus 25. Then you would have gotten, this would have been 10b minus 5, 10b plus 5. But the problem is with this is now this term has a common 5 to both of those terms. So does it here. Okay? And then you'd have to factor those out. You'd still get down to this point right here. You're always better off taking out the largest common factor that you possibly can. Right? So here we go. Remember, the square root of x to the fourth is going to be x squared. So this will be x squared minus 9, x squared plus 9. And then just like we saw a couple of questions ago, this x squared minus 9, this is also a difference of squares. X minus 3, x plus 3. But x squared plus 9 isn't. That's a sum of squares, and I don't have a rule for factoring that, so I would leave that as just x squared plus 9. That's all you have to do. And finally in this lesson, we will look at some simple trinomial factoring. All right. Now we're going to look at factoring trinomials here. Now, the real trick to this, let me give you an example here. Let's say that I've got, let's say x plus a, x plus b. Okay, just to kind of show you a general form. And again, I'm going to work forward from expansion, and then we're going to practice going backwards here. When you multiply that out, you're going to get x squared plus, well, bx plus ax plus ab. And then those two middle terms there, because remember, x is the variable, I can factor out the x. And then I'm going to put these in a better order here. I'm going to make this a plus b, because order doesn't matter with addition. X plus ab. So notice that what's going on here is if we were to factor this, the numbers that we're looking for, this x plus ax plus b, notice that the last number in the trinomial, that's the product of those two, and this coefficient of the linear term, the x, is the sum of those two. So if we can find the two numbers whose product is this number and whose sum is this number, then we can fill in the binomials. So let's just take a quick look here. So let we ask ourselves, what two numbers have a product of 6 and a sum of negative 5? Well, you think about a product of 6, that could be 2 and 3 or 1 and 6. But if their product is supposed to be positive and their sum is negative, they both got to be negative. And negative 1 and negative 6 won't do that, so it's got to be negative 2 and negative 3. When we think about that, you multiply those together, you'll get negative 2 times negative 3 is positive 6. Negative 2x, negative 3x, yeah, there's your negative 5x. So that's the factored form of this. Here, what are two numbers have a product of negative 15 and a sum of negative 2? Now that one's a little bit more clear, because for 15, the answer, the numbers are basically going to be 3 and 5. But if it's negative here, now let's think about this, it's going to be a and a. If it's negative here, that means the larger number had to be negative. So this will be minus 5 plus 3. Let's just double check that. Negative 5 times 3 is negative 15. And then I would get negative 5a, 3a, yeah, together that's negative 2. Yeah, there it is. Here, what are our factors of 30 that have a sum of 11? Now, with factors of 30, Okay, what is it? We got 2 and 15, 3 and 10, 5 and 6. Now it should jump out at you almost immediately. Yeah, 5 and 6 are going to give me 11 here. And notice that everything's positive here, so this would be m plus 5, m plus 6. Now, if you ever put the factors in a different order, that's okay, because like if you make this m plus 6, m plus 5, that doesn't matter, because order doesn't matter for multiplication. Okay? Down here, this one, b squared minus b minus 30. Okay, so I'm looking now for factors of negative 30 that have a sum of negative 1. Okay, well again, I got 1 and 30, nope. 2 and 15, no. 3 and 10, no. But 5 and 6 again, yeah, that would work. So b squared, if it's going to be negative, then the larger number has to be the negative one, the smaller number has to be the positive one, so that the sum ends up being negative 1 there. And there we go. That's how that would have to factor. Okay, x squared plus 2x minus 48. Okay, I'm looking for factors of negative 48 that differ by 2. Okay, well 48, what are that? 1 and 48, no. 2 and 24, no. 3 and 16, no. 4 and 12, no. But 6 and 8 do differ by 2. So I've got x and x here to get the x squared. It's positive 2, this is negative 48, so their sum is positive, their product is negative. One of them is negative, one of them is positive. The larger one has to be the positive one so that their sum is positive. So it's got to be x plus 8, x minus 6. Okay, now, before we factor this one, notice we got a number up front here. What we want to do, if we can, and it's not always possible to do this, and that then would require a different kind of factoring here, a slight variation on it. I'm going to take out the common 2. And that'll leave me with m squared plus 9m plus 20. Okay, now I've got a trinomial here, but don't forget about the 2 that you pulled out. So this will be m and m. Now I'm looking for factors of 20 whose sum is 9. And for most of us, when we talk about factors of 20, your head goes to 5 and 4 immediately anyway. And yeah, those add up to 9. So there we go. Those are the factors that we're looking for. All right. This one right here, now take a good look at it. Again, we got this number up front here. If we can get rid of it by factoring it out, that's great. Now if we can't, there are other things we can do, but in this case we can get rid of it. So we take the 4 out and we're left with x squared, okay, plus 6xy plus 9y squared. Now don't let the presence of the y in there throw you off. Notice you've got x squared, no x, no y, y squared. So essentially this is going to be x here, y here, x here, y here. That's all that means. You just got to fill in the pattern like that. Now, what are the factors of 9 that add up to 6? Well, 3 and 3. So this would have to be plus 3y plus 3y. And now someone's going to ask, could I write this as simply 4 times x plus 3y squared? Yeah, sure. Yeah, absolutely. Go for it. This one right here, again, look at the presence or the pattern of the A's and the B's. It suggests that this is going to be A, this is going to be A, and that there will be B's at the back end there. Because notice there's no B here, there's no A here, they're together in the middle. Now, what are my factors of negative 7 that add to negative 6? And the beautiful thing about this one here is that 7 is a prime. It can only be 7 and 1. Like it can only be 7 and 1. Now, but the question is, what about the negatives? Well, when I add them together, I'm getting a negative 6. And when you multiply them, you're getting a negative 7. So one of them's negative, one of them's positive. And because their sum is negative, the larger number there must be the negative one. And over here, again, we've got this leading coefficient that's not 1. So let's see if we can factor it out. And we can. We're left with x squared minus, oh, sorry, that's not 12. I don't know why I read that as 12. That's so interesting. 21. So take a 3 out of that, you get 7x. And then plus 10. Okay? Now, what are my factors of 10 that add to negative 7? Now, because the product is positive and the sum is negative, I already know that those two numbers must both be negative. Okay? So what are the factors of 10? Well, 1 and 10, 2 and 5. well, 1 and 10 doesn't get you 7 there, but 2 and 5 would. And so there's my factored form, 3 times x minus 2 times x minus 5.